Might walk around the shop here a little bit and see what's happening, and I'm talk a little bit about what I do to plan certain jobs, and in particular this job I'm just starting on, that this blank that I've started to prepare in the Mazak here. I posted a little video I took with my phone on this. I was just turning the end, which actually is up in the chuck here right now, and I flipped the part around and I turned this down because it was the raw piece of stock. We found a extra piece of material here at Centerline, and it was 5.5 inches, and I had to turn it down to 4 3/4 inches in diameter. That's what this part is. And what I'm doing, this actual material is going to be titanium, and it's going to be a very complex. Well, the part to start with is going to have a lot of gun drilling and everything in it that I don't do. So if I make a mistake, I don't want to pay for that expensive piece of material plus all of that labor and everything to put those holes in. So I want to make sure I have things right on this setup piece first. So that's what's happening with that. And here's some material or tooling, I should say, that I've been gathering here. And I'm going to talk about this boring head here in the video, and some longer drills just to establish actually the bottoms of the holes, mostly in this case on this, and a piece of stock that I'm gonna set up with this smaller chuck in the Mazak to turn this boring bar that's gonna replace. It's gonna be a bar similar to this, but I'm gonna explain that in the video a little bit later. But there is some kind of interesting stuff that's been happening here. Over here they moved all of these machines. They moved these machines over here, and they've actually sold. They had 4 of these quantum mills that I actually purchased when I owned the shop a long time ago, and they sold all 3 of them all but this one, and they moved this one here. And there used to be that Haas mill that I just showed you that they moved over to there. So this quantum is next to my horizontal right now in this case, and they cleared out this whole area over here. All the workbenches are kind of moved out of here right now, and there was 2 cranes they had to take out of here, and there's the column for one of the cranes they took out of there. And they cleared this whole area. As you can see, this is where all those quantum mills were, in this whole area here. And they've they've purchased a new VF5 and 2 VF6s, Haas VF6s, and they plan to get, if I understood them right, 3 more machines, 3 more of these VF6s, I think, is what they told me, which is going to be put all in this area now, here, up to where those, if you can see them over there, those 2 VF5 Haas's are. They're going to face them toward each other like those machines are. I guess they've decided that they like that configuration of the machines facing each other with the kind of like these benches on the side they've built here. So that's what they're going to do in this area. That's what they're talking about. So that's kind of interesting. So these 3 machines are brand new, came in last week. These are these 50 taper Haas's, and they've been having pretty good success with these machines. You know, I know people downplay Haas mills a lot, but I don't know. They seem to be working all right for them. They have a side tool changer on them. That's some of the things that has been happening around Centerline here. Kind of cleared out all those green machines like this one here, and are replacing them with those Haas mills. Here's the small Indicrex over here. It's an i400 machine. He's got it kind of covered up with those lights, but that's what it says there. This is a nice little machine. He's making a relatively detailed part there on it. Kind of interesting. That's kind of what's happening around the center line, or the new things that are happening. I've got another batch of these things to make. They must be melting that stuff down. I've been making a lot of those lately. So like I said, they moved all the other Haas machines over here. So they got over here they got two VF5s back behind there, and this is a VF3, and two of their horizontal mills right here. So anyway, I want to just talk about, in this video, about the things I think about when I go about, here's a fixturing for the Super Duplex parts that I worked on. Here's some other fixturing. That's my stuff here, stacked up here, kind of in a mess. But I want to talk about what I think about when I first get a job and I'm looking at it, and I have to go through and gather up tooling, because I don't have a tool crib person that helps me, so I got to do all of it. You know, I got to figure out what I need, gather the tooling up, order it, and get it all going. Some end mills here from Bass to start this job. So let me get into the explanation of the CAD part, just of what I'm thinking about on this job, and show you about this boring head. I think we're going to start with this boring head and making this this special bar for this boring head. First, looking at a job and what I think about when I'm getting ready or planning to do the job, and what I need to gather up in the way of tooling and make for fixturing and such as that. Now this is a part I've been starting on here recently, and this is the blank that I'd be provided. I can't really go into real good detail here, but I just want to show you a few aspects of what I was planning to do with this. Now this is the blank after I've done some work to it, just a drilled blank. And what I'm concerned with is really the end of this, what I want to talk to you about. That I'll zoom in on it here. Really can't show you too much detail about all of this. And we'll go with the part here. We're just going to look at a section through the end of this part so I can discuss what I'm going to talk about with the tooling that I'm going to need to make. Now these bores are in particular is what I have to work with here. Now I could do all this with milling tools on the Integrex, but I would need a number of tools because this is off center. The actual center line of the part runs down here somewhere, and all of this feature here, which is right here, is all off center. And so I'm thinking that this would be better to turn it in the lathe. It would just be, or turn it with a lathe turning tool, I should say, and it would just be easier to do it that way. So, but anyway, what I am planning to do here is if I need to run this part off center, I have to figure out something about how to do it. And so this is what I'm planning to do. I want to make this device that's sort of like a it's a sort of like a two-jaw chuck collet-like thing that I can adjust these tapered pieces to get the part to run concentric in the, the off-center direction. And so I'd have to build this device, and then I have to balance this part somehow, because it's going to be running off-center about 7/16 of an inch roughly
off the center line. This center line here is the center of the part, the actual part, but in order to do the bores here, we'd be running off center. So we need to balance this a little bit. Now the part is titanium, so it's not that heavy, but it still needs somewhat of a balancing thing. So this is what I've come up with for the balancing weight here to balance this so I can do my lathe operation on this end of the part. Now, how do I actually determine how much this has to be and everything is in this CAD software? I can define what the material is made out of. I just more or less defined all of this balancing weight material as steel, and this device is also going to be steel. So, and I can define the parts blank as titanium, so the CAD software can actually calculate this for me. So if we look at the very end view of this, if we take a selection around everything here, and we go over here to the measuring part of this software and measure the mass of this, it'll give us the center of balance of all those assemblies together. So this is what we're looking at now. The center would ideally be here, but I'm gonna let it overbalance just a little bit because I have to actually do two different setups, and this is going to be a offset a little bit more on the second one. So I'm trying to. This is the second one is going to be here. If you see that little dot, and this one's going to be here on this end. So I'm trying to use the same weight and everything for both setups, and that amount of overbalance won't be that much problem with the lathe, whereas it would be if it was just only the balance point of this is the center line of the part. So this is approximately about 7/16 of an inch, if I remember right, roughly. It's not exactly that. So this is the one way that I determine the how to design my balancing weight and everything. I've done this before and it's worked pretty good. It's close enough. It's not perfect, but it's close enough. If I look at the side view, you can see where the center of gravity, of actual gravity is, but the center longitudinally in the length of the axis of the rotational axis of the lathe. It's not really critical. What we're more interested in is the center of the, although I could move this weight back and forth, I guess, to compensate for that, but what we're more interested in is the center of the balance on the rotational balance, I guess you might call it, which is going to be, of course, the center line of wherever this is pivoting. Now that would be the ideal spot where my arrow is. But if we actually measure this with the software, it'll be a little bit further beyond. And also, I'm thinking this will help me because of my chuck jaws on my 4-jaw chuck. This jaw down here will be hanging out more, so it'll offset this a little bit of overbalance back maybe to where it should be a little bit. So that's just one aspect of this I'm looking at. Another aspect is is a special boring head that I'll need. So here's a section through an area of the part that has these holes, and in order to bore these, I need to do something with the boring head, and the boring head I have, or the boring head's parts and stuff that I have, won't quite do this exactly the way I want it, so I have to build this special boring bar for the boring head. If we just open this boring head by itself, this is an ISCAR ITS boring head that I have, and I have this cartridge thing that goes on there, boring bars, and this is just a Capto adapter that mounts their shank to the Mazak spindle. But this bar here, they don't really make one the size I want. I want to be able to have the best rigidity, and if we go back and look at this picture, I need to bore it all from this side because this bore here has to run concentric to these bores that this bar is going to cut. So I need to make this boring bar. And so the videos that I'm going to try to make on this, I can't really show too much about the part itself, but I can show you my fixturing and what I'm building to do the part. And so I'm wanting to make videos about that, at least to show you guys what I can do with that. So I think the first video is going to be about making this bar here for the boring head, this ITS boring head. And in a second I'll show you the boring head and what's involved, or why I need to do that. Here's the boring head I was talking about on the CAD model. There's just a rough model of this head that I downloaded off ISCAR's website to get the dimensions of this, but this is the head as it comes from ISCAR with their MB taper mount, they call it, which mounts onto this happens to be an adapter for a Capto shank. This is longer than I'm going to get a shorter one than this, but this gives you the general idea. And so this mounts in here like this. So that's how it goes together. And this has this kind of double pin thing that expands out into these tapered bores in the adapter here, and it kind of sucks this thing into this taper, so this all makes up very solid, and it's really a good system, actually. I like it. But these are the kind of the example of the boring bars you can purchase for this boring head. I've modified this one a little bit here, but generally it looks like this with a radius, but I needed clearance one time, so I machined the radius away. And they mount in the head with this dovetail-like system, so you can adjust this back and forth to get a rough diameter setting of where you want your bar to be, and then you of course adjust the diameter with this adjustment to get a precise setting. But this bar is smaller in diameter than I want. It's about 1.062. I want to have about 1.2 inches on the bar diameter, and it's longer than I need, actually. See, this will reach almost 5 inches down, and I only need to reach about 4.4 to the insert. So this might lack a little bit of rigidity and give me problems. I don't know. So I want to make a heavier bar, and I want to capture more of the boring head's dovetail system here. So if you remember from the CAD model, this comes out wider here in this dovetail to give it more strength. Although it may not be necessary, but I'm just going to do that just to be safe. And this is the same cartridge I'm going to use, except I'm going to have to machine or grind off about 100 thousandths off the back of here, because this won't fit in the bore I want to do. It would rub on the back here. So that's the boring head. I've kind of gone on and on here a little bit longer than I wanted to, but I wanted to explain this stuff. And there's plenty more to come with this deal and this steady rest spider-like thing, I call it, to support the part, and the boring head, the boring bar, and other stuff that's going to be necessary for these parts. The special tools to be ground. This is kind of an involved job. There's, I think, about 9 of these already on order. There's going to be more, they tell me. So I think that's going to be it for this video for the time being. And we'll start with the machine work on at least this this boring bar thing here, the boring head, in the next video.